Our local group is racing through the universe at roughly 630 kilometers per second, partly toward a region hidden behind the Milky Way. It was named the Great Attractor, but it is not a black hole, an alien object, or a cosmic drain. It is a clue that the distribution of matter across hundreds of millions of light-years is steering the motion of galaxies, including ours. To understand the clue, separate two kinds of motion. Space expands, so distant galaxies generally recede in the Hubble flow. But galaxies also have local, extra motion caused by gravity, called peculiar velocity. By comparing a galaxy's independently measured distance with its redshift, the stretching of its light, astronomers can see when it moves faster or slower than expansion alone predicts. The evidence for this local motion is the cosmic microwave background, the faint afterglow of the Big Bang. It appears slightly hotter in one direction and cooler in the opposite direction because our local group is moving through it. This dipole pattern gives the roughly 630 km per second figure. In the 1980s, Donald Lynden Bell and colleagues mapped these peculiar velocities and found that nearby galaxies were not moving randomly. Many were streaming toward a direction near Centaurus, close to the crowded band of the Milky Way. That band is the zone of avoidance, where gas, dust, and stars in our own galaxy block much of the visible light from what lies beyond it. Early models represented the pull as a hidden concentration roughly 150 to 250 million light-years away. The name Great Attractor stuck. But modern observations show it is not one object. There is no giant black hole swallowing galaxies. The pull comes from a network of galaxy groups, clusters, hot gas, and much more dark matter than visible matter, spread across an enormous region. Gravity is not pulling against cosmic expansion everywhere. On sufficiently large scales, the universe still expands, but within local regions, extra mass creates deviations, just as a valley redirects water flowing downhill. One important structure is the Norma cluster, or Abell 3627, about 220 million light-years away. It lies almost behind the Milky Way's disk, and infrared, radio, and X-ray observations have helped reveal it. Yet Norma alone does not appear massive enough to account for every observed flow. The Great Attractor is better understood as a regional gravitational feature, a concentration in the cosmic web, not a single target. Visible galaxies are only the glowing markers. Their motions reveal a much larger gravitational map, because dark matter supplies most of the mass holding clusters together. In 2014, a team led by R. Brent Tully used galaxy motion data to define Laniakea, the flow basin containing the Milky Way, the Virgo cluster, and the Great Attractor region. Laniakea spans roughly 500 million light-years, but it is not a rigid, permanently bound island of galaxies. Its boundary was mapped by tracing how galaxies flow through space, like mapping a watershed by following rivers. Even Laniakea is not the whole answer. Far beyond the Great Attractor lies the Shapley supercluster, around 650 million light-years away and one of the most massive concentrations in the nearby universe. Studies of cosmic flows indicate that Shapley contributes to our motion as well. Other analyses describe part of the pattern as motion away from a large, underdense region, nicknamed the dipole repeller. It does not literally repel. Matter flows away from comparatively empty regions toward denser ones. That is the real picture. The Milky Way is not being dragged to one mysterious point. It responds to the combined gravity of an uneven universe, while the expansion of space carries the larger cosmos apart. The exact share of our motion, caused by Norma, Shapley, Virgo, dark matter, and local voids, is still being refined. Infrared maps, radio surveys that penetrate dust, X-ray studies of hot gas, and distance measurements from thousands of galaxies are gradually filling in the zone we cannot see. No spacecraft could ever photograph this flow directly. It is reconstructed from millions of measurements over many decades. The Great Attractor is no longer a monster hidden behind the Milky Way. It is better a measurable sign that invisible structure shapes the universe on scales where entire galaxy clusters behave like particles in a flowing cosmic landscape. Follow for more real space mysteries. And tell me, does knowing our galaxy is part of this enormous gravitational current make the universe feel more connected, or more unsettling,